So this just says 120 vehicles in the teacher's parking lot today. 30 are pickup trucks. What's the experimental probability that a vehicle chosen at random in the lot is a pickup truck? Like, how would I figure that out? Exactly. So 30. We didn't have to do any studies about like what's the average number of people that have pickup trucks or anything like that. It's experimental probability means you have to have some kind of data, and we'll go from there. So this is actually just 1/4. So if you want to do that as a decimal 0.25 or as a percentage, 25%. So if I randomly selected a teacher that parked their car 25%, we would expect 1 out of 4 would be a pickup truck. Okay, now this one's a little tricky, I'm not gonna lie to you, but it's not bad. So this is, what's the theoretical probability being dealt exactly? So that means, if you see the word exactly, that means only. So exactly 2 7s in a 5-card hand from a standard 52-card deck. Okay, so if you guys are, we talked about permutations and combinations, right? So permutation, the order matters. Combination, the order does not matter. So if I deal you cards, and I'm just going to deal you 5 cards, does it matter the order that they come to you in? Because they're all going to be in your hand, right? It doesn't matter. Okay, so we're going to do a combination. So I'm going to do number of possible ways. So I'm going to do the number of combos, of how I could get 2 7s. So in a deck of cards, do you guys know how many 7s there are? 4 total. Okay, so in the deck of cards, there's 4 7s. So I have 4 7s, and I need 2 of them. So it would be that 4C2. So we have to have 2. Okay, now. Do what? The combination. I don't know if we were doing that a couple days ago. We're going to do that on the calculator. I'll remind you guys where those buttons are. So that's a combination. So that's a 4, choose 2. All right, now. Math and then the probability menu across the top. And I think it's the 4th one down. Okay, don't calculate that yet, just for a second. Okay, now, the rest of the cards could be anything else, right? So I just want 2 7s in this hand. So if I have 5 cards in my hand, I need 3 more cards. All right, I need non-7s. Okay, and I would need 3 of those cards to fill out my 5-card hand. So how many, if I remove the 7s out of the deck of cards, how many cards would I have left? 48, exactly. There's 52 cards in a standard deck. So out of the 48 that aren't 7s, I need 3 of those to be some other card. Okay, this is going to be kind of like the top of my fraction. We'll do this in a second. All right, now, just number of 5-card hands is how we're going to calculate the probability. So if I deal you cards, again, we're using a combination because the order doesn't matter. You're just going to have all the cards in your hand. So if you have a 52-card deck, you're going to get 5 cards dealt to you, so it'd be 52, choose 5. That would be the total number of hands. We're going to figure out the probability that we would have exactly, meaning only 2 7s. To get that probability, you take these 2 guys and multiply them together. So we're going to do the combinations that only have 2 7s times the combination. You can do this all right in your calculator that only have 3. So 2 7s, 3 of any other card, divided by the total number of 5-card hands. It should be. It's a probability, right? It's got. That's okay. Here. Now, if you guys forget where this is at, if you have a scientific calculator, find that PRB button. You got to type the number first. So I'm going to type 4. If I got a graphing calculator, we're going to hit math and then probability. C is for combination, so NCR is the one I want to do. Just hit enter. It should bring you back to the main screen. Put the 2. And then I'm just going to arrow over, and I'm going to multiply that, and I'm going to type in 48 math, and then I want to do, for the 3 cards, 48, choose 3. This would be the top of the fraction, so I'll just do these separate real quick. 103,776. That would be all the hands that would just have 2 7s, which is a ton, right? But you got a lot of cards in the deck of cards. You got 52, so there are over 100,000 different hands you could get that just had 2 7s. Now, the total number of cards, I'm going to type 52, hit math or hit probability if you got a scientific, and then under the probability menu, if you're on the graphing calculator, under the probability menu, do the NCR if you're on the scientific, and then just 5 card hands would type in 5. So the total number of hands we could be dealt, there's a ton here, as you guys can see. I've got 2,598,960. So if you are playing cards, that's how many different hands you could get if you had 5 cards in your hand. To calculate the probability here, I'm just going to divide these guys. Make sure I don't forget a number as I type that in. And I get 0.03, and you guys can see that's like 992. So I'm going to say this is about, just round that to a percentage, would be about 4% chance that we would get 2 7s only in our deck, or in our hand of 5 cards. I have one question like this on the homework, and that's not exactly related to what we're doing today. Does anybody have a question? And if you can't find that button on your calculator, I will come help you as soon as we are done with this. Okay, now we're going to talk about law of large numbers today. So law of large numbers says that with a blank, and this is going to say large number. If you have a large number of trials, okay, experimental probability, remember that's what we look at if we have data or we perform an experiment, will actually approach the theoretical is what should happen, probability or actual probability here. Now, what we use, because sometimes these things would be hard to actually do an experiment with, it says sometimes actual trials, such as flipping a coin 1,000 times. You're not going to sit there and do that unless you're really bored, probably. So they're difficult to actually perform the experiment that you might want to perform. So what we can use, you can use computer programs. We're going to use a program today on the calculator that'll do it, or I'm going to give you the data, which is what the Math Excel will do. But you can estimate experimental probability using like a random number generator, or we can use a simulation and model in the calculator. It's called a simulation. And we're going to try this here. I'm going to give you guys the theoretical probability here real quick. And then I'm going to show you, if you want to do this on the calculator, you can, or if you want to just use the data I'm going to get on mine, you can do that too. So theoretically, we're going to start here. It says theoretical probability, experimental probability of getting tails in the number of trials. So if you flipped a coin 10 times, theoretically, how many tails should you get? 5, right? Theoretical probability, you'd get 5 out of 10, which would be 0.5 or 50%. Okay, if I flipped a coin 100 times, how many tails should I get? Okay, I'm just going to have a heart attack. 50, right? That's what I should get, theoretically. If I did it 500, what's half of 500? 250. All right. So all of these would be 0.5. That would be the theoretical probability. Now, the law of large numbers, whoops, I just messed that up. Sorry, 500 out of 1,000. The law of large numbers is going to say the more trials we perform, the experimental probability should approach that 1/2. Have a good weekend. Okay, now, if you guys have a graphing calculator, and if you have an 83, you still have this, but it might look a little bit different. You want to look for a menu that says apps. It's like APPS. It's right next to the math button if you got the 84. Huh? It is. It's under there. If you click on apps, and it's just going to depend on your calculator. You might have different stuff than mine. I'm going to scroll down here. What you're looking for, and if you're in an 83, it's probably closer to the top of the menu. it'll say PROB simulation, or it stands for probability simulation, but that's what you're looking for. So I'm under the apps menu. It's right next to math probability simulation. Just hit enter. And you can do different stuff. There's a bunch of different things that are programmed in here. We're going to do toss coins. So I'm just going to hit enter. And the menu that you're going to use is kind of across the bottom of the screen. It doesn't. It doesn't.
I just did it 10 times, you know, 5 and 5.
Okay. Well, maybe not. It depends on your calculator. So if you want to toss one toss, it's the window button. It's the button right underneath. So I'm just going to toss one time. If you guys have an 83, you can use the arrow keys. And if you have an 84, it will tell you the frequency, meaning how many. So for my first one, I just did 1. Okay, now I'm going to go up to, I'm going to keep tossing this, the +1. I'm just going to go up to 10. And it should tell you on the screen, like on mine, it tells, like I've done it 4 times. So I'm just going to count up real quick to 10. Well, but you can see right there, mine's not. So just depending, you can write down yours or you can write down mine. Okay, if you want to see the actual things, if you have an 83, just use your arrow keys to arrow over. If you can highlight the bar, it'll tell you how many. If yours is like mine, like if I highlight heads, it tells me this is 4, tails, it tells me 6. I'm going to write down mine just for my notes here. So I got 6 out of 10 on mine. If yours is different and you want to write yours, that's fine. But it's not exactly what it should be. Now, you can toss, you don't have to do one at a time. Like you can toss 10 at a time or 50 at a time. So the next one says 100. So let me toss 50. You're still at 50%?
Oh, no, they're off now.
Okay, I was going to say, I'm surprised by that. So I tossed 50. I'm going to try to get that number up to 100. So then I'm going to toss 10 4 times. And then you guys can see mine. Let's see what I got here. My tails now, interesting, 60. And my heads are 40. I'm just recording tails in the notes because that's what it asked for. So this is actually 0.6 again. That's weird. That doesn't usually happen. Okay, now the next one, I got to get it up to 500. So I'm going to toss 50s just till I see that number up here in the corner. Till I see that say 500. Should just be able to keep tossing 50 at a time. There we go. Okay, now I have 264 out of 500. And fail, I don't have, I'm going to keep that on my screen. Let me see what that is as a percentage. Okay, so now I'm at 0.528 for mine. Maybe yours is a little bit different, but you should be approaching 0.5 the more you do. Okay, now I'm going to throw 50. I'm going to get this up to 1,000. And it should, the closer or the bigger the number of trials you do, the closer it should be to the theoretical probability. So the closer it should get to 0.5. Ooh, mine's not going to be that way though. All right, so my tails, I got 550 out of 1,000. Let me see what that is as a decimal here real quick. So now I'm at 0.55. So the theory is the more I, like if I, shoot. I hit that button one too many times. Okay. This was actually out of 1,050 for mine, forgive. Now I have to recalculate that. It should approach 0.5 as you get bigger and bigger and bigger. I just realized that. So I'm going to do 550 divided by 1,051 for some reason, 50. Okay, so this is 0.52. I accidentally hit the button too many times, but it should approach 0.5 the more simulations you do. So the more trials you do, you should get closer and closer to 0.5. That's what that's supposed to show you. Item has 4 choices, so like A, B, C, D, but your calculator is going to use numbers, not letters. How could you simulate guessing? What's the probability you'd pass if you just guessed? All right, so this is going to be 10 multiple choice questions, and in the display here, just so we all have the same thing, there are 20 different trials, so like 20 different people. Okay, if you want to try this on your calculator, you can do this. It says you can use a random number generator. There's apps on the computer for this as well, to generate 10 numbers. And what we did from 1 to 4 to represent the 4 choices. So like A, B, C, D. This one says let 1 represent that you got the correct answer. And then 2, 3, and 4 will just represent that you got the wrong answer. If you want to actually try this yourself, the little directions for doing this down on the bottom, if you do math and then the probability menu, I don't know if the scientific will do this. I'd have to come look at it. I don't know if they do or not. So probability menu, and then there's this number 5. It might be a different number on your screen, but that stands for random integer. So R-A-N-D and then I-N-T, random integer. I'm going to hit enter. Okay, so what we did, we're going to type 1 here, the smallest number, 4 here, and then n is the number of questions, which is 10. So we're just like A, B, C, D, so we did 1 through 4, and then the number of questions is 10, and you just hit enter. And if you want to hit that again, it will just keep generating different sets of 10 random numbers. I just did it on the screen just in case people didn't have graphing calculators. But you can do this with more than that numbers, but you can generate random digits to create a simulation. Now, I should have made this smaller so we can see it all on the screen at once, so I'm going to do this real quick. So this says simulation, the person randomly answered multiple choice questions. 1 represents the correct answer. So I'm going to grab a highlighter here real quick. So every time you see a 1, that person guessed correctly that question out of 10. So the number, this first person got 3 correct. So out of 10, their percentage, that would be a 30% for that person. So if I just keep going down, like this next person only got 1 of them correct from guessing. So it'd be 1 out of 10. So they'd get a 10% on this quiz or test or whatever. This person, I don't see any 1s. So they literally got nothing, 0 out of 10 correct. So they would have had a 0% from guessing. Let me see here. I'm just going to go through and count the 1s. So I'm just highlighting them with my little pen here real quick. Person number 4 got 3 correct. Person number 5 also got 3 correct. Person number 6 also got 3 correct. So those would all be 30%. Let's see, person number 7, ooh, this person is a better guesser. They got 4 correct, so that'd be 40%. Person number 8, 1, 2, 3, they're back to 3 correct, so 30%. Person number 9, we got 1, 2, 3, 4, so they got 4 correct. Person number 10, looks like they only got 2 correct, so they got a 20%. Person number 11 also only got 2 correct. So these people guessing is not a great strategy for your grade here. Let's see, now person number 12. 1, 2, 3, 4, 5, 6. This person got 6 correct. Person number 13. 1, 2. And then if we had more trials, then we'd have more information. We just did 20 here. So a lot of people are doing, this person, number 15, didn't get anything correct. Number 16, they only got 1 right. 17, looks like they got 3. 18. 19, person 19 only got 2. And person number 20 got 1, 2, 3, 4. Okay. Now, the question at the bottom here says, what's the probability of passing the quiz, which passing grade would be 60 or higher, if you just randomly guess based on the simulation that you have in front of you? Did anybody pass this quiz? Literally just this one person in line 12. That's the only person that passed this. Everybody else's scores are way below that or below that. So I have 20 different trials listed, so your probability here would be 1 out of 20. So this would be 0.05 as a decimal, or only 5%. So perhaps the moral of the story is we should not randomly guess on multiple choice, and we should actually study. So, anywho,